Okay, welcome to lesson 2.2 where we'll be discussing just elementary functions, basically their graphs and transformations. So we're going to be going over what we call elementary functions, or in other words, parent functions. Okay, so first one is of course our constant function. It's just a horizontal line where y equals a certain number. We have our identity function, or in other words, y equals x. Our absolute value function looks kind of like a V. Our quadratic function looking like a U. Our square root function, and our standard cubic function, and our cube root function, where it just reflects over the line y equals x. Okay. So if we look at each of these, here's the information down below on each of these functions. Our domain and range, and that's an even function. Here for our identity function, it's an odd function. It revolves around or reflects over the origin. Here we have our domain and range, our absolute value function. It's also an even function. Domain and range for our quadratic is an even function. Our square root function is neither even nor odd, and it gives our domain and range there. Our cubic function, which is an odd function, and so is our cube root function. So let's look at types of transformations: vertical, horizontal shifts, reflections, stretching, and streaking. So if we look at a standard quadratic function, so let's look at y equals, and we'll do a parentheses b parentheses x minus h, close both parentheses, squared plus k. Okay, let's look at what each one of these do. As we should know, our a here is a vertical stretch or shrink. Or shrink. Okay, we'll go over this, but a stretch is when our a is greater than 1, okay? And that's going to be the absolute value of a, because if we have a negative in the front, then that's going to be a reflection, okay? So if a just being greater than 1, the number being greater than 1, and then a, the absolute value of a being in between 1 and 0 would be a shrink. However, B right here is going to be our horizontal stretch or shrink. So if we always think about, I always look at it as, the best way I can explain this is when you're hanging out with the x. In this case, it's a quadratic. But if I had a square root function, if you're hanging out in with the x, then your b is in there. You got your parentheses x minus h. It's in with under the square root with the x. Okay, you have your a on the outside and plus k. Okay, so in with the x deals with horizontal shifts. Okay, we have a horizontal stretch or shrink for the b, and then behavior is opposite in here with the x. Okay, so think that inside here behavior is opposite. Okay, that didn't write too well, but let's see. Okay, so in here with the x. So that means a horizontal when the stretch will be when you're in between 0 and, let's do b here, sorry, in between 0 and 1, and a shrink will be when b is greater than 1. Okay, and of course absolute value as well, because if the negative is going to be a reflection as well. So outside of dealing with the x is going to be your vertical transformations, okay? So in front is your vertical stretch or shrink, and then this is vertical shift up or down. Up or down. And then the h would be a horizontal shift, left or right. However, behavior is opposite. So if I have a minus here in front, then it's going to be to the right, and if I have a plus, it's going to be to the left. So this one is going to be left or right. Okay, so that is our information with our transformations. So let's go through these fairly quickly. So the graph of y equals f of x plus d is the graph of the shifted d units, what? Up, right? Because we're not in with the x. If it was in with the x, it would be in this parentheses with the x. It's a d, it's on the outside, so I'm dealing with vertical transformations up or down. Minus d will be d units down. Okay. So if we have the absolute value of x, well, normally that's going to be our v right there coming off at the origin, right? So I can take this and I can shift my origin up 3. So I'm just going to go 1, 2, 3. Now here's my origin. My absolute value is a slope of 1, and it's going up that way and up that way. That became a box there. Let's just put our arrows there. Let's look at x squared minus 4. Well, we know our x squared is a parabola, but it is minus 4, so it's shifting down 4. Not left or right because nothing's in there with the x. It's just down 4. 1, 2, 3, 4. That's my new vertex. And if I go 1 to the right, 1 squared is 1. If I go 2 to the right, 2 squared is 4. So I'll go 1, 2, 3, 4 is my next point. 3 to the right would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my next point. So I go over 1, and then I can go up 3, and then I can go up 4 more right there, and that is my parabola. And put some arrows on the end there. Okay, so just shifted down 4. Well, what about if I'm inside with the parentheses here and it's a plus, behavior is opposite. So instead of going right, I'm going to be going to the left, C, C times however many, shifted to the left. This one is minus C, so I'm going to be shifting to the right. So if I have x minus 4 squared, well, that'll be my normal parabola. However, I move to the right 4, so instead of my vertex being at 0, 0, went to the right. And I know I can go up 1 and then over here up 4. And so just put my, okay. X plus 3. Well, I'm inside with the x, so I'm going left 3 since behavior is opposite. And that is my absolute value function. So I'm just going to be going up with a slope of 1 and up with a slope of 1. Okay, now with our reflections. Negative on the outside. Well, if we think of negative on the outside, outside not with the x deals with vertical, right? So I would be reflecting over the x-axis because I'd be reflecting vertically up and down. Okay. So when I have the negative out there, then that's going to be reflected about the x-axis. And then when I'm in with the x, the negative in there, it's going to be reflecting about the y-axis. So let's look at this. This is a square root function, but I'm reflecting over the y-axis. So if I think of my normal square root function, right, out here like this, well, then I'm going to be reflecting that over the y-axis. That's going to erase for me. Okay. So if I think of square root, well, the square root of 1 is 1, so I can plot my point here. The square root of 4 is 2, so I can take my square root function and do it out like that. And it starts at 0, 0, going off from there. Okay. Let's see if I can get that last one off. No, it doesn't like my erasing there. So interesting how this erases. Okay. Our next one, there we go, is negative. So, I mean, on the outside. So instead of it reflecting over the y-axis, it's going to be reflecting over the x. So instead of going up 1, I'm going to be going down 1. 4, square root of 4 is 2. So I'll be shooting off from there, off like that. All right. And then here we have our stretch or shrink. A on the outside be vertically, and if it's greater than 1, then it's vertically stretched. Okay, and then if it's in between 0 and 1, it's vertically shrinks or shrunk. Okay. Shrinks by. Okay. So here, let's look at how we graph these. Absolute value of x normally has a slope of 1. Starting here at 0, but I think if I normally go 1 away, I go 1 up, right? But now it's multiplied by 2, so when I go 1 away, I'm going to be going up 2. 1 away this side, up 2. 2 away, then I'm going to be going up 4. And 2 away here, up 4, so forth and so on. And so it's stretched away. When I think vertically, okay, stretching, it's away from the x-axis, okay, away. So I'm stretching away from the x-axis by a factor of 2. So here is a vertical shrink by a factor of 1/2. So instead of being at 1 when I'm away from the x-axis, I'll be at 1/2. And if I go 2 away, instead of 2, I'll be at 1. Let's go on to 4. Instead of 4, I'll be at 2. Instead of 6, I'll be at 3. So I'm stretching away from the x-axis that many. 2, 4, 6, and like that. Okay, so it's away from the x-axis is my stretch, or this was a shrink by 1/2. Okay, horizontal shrinking. Okay, if I'm in with the x, this b here, okay. Now, if it's greater than 1, then it's a horizontally shrinks. Okay, and by dividing, so really by a factor of 1 over b. So if I had, let's just do this one here, 4x, and I do squared. Well, then I'm going to shrink by a factor of 1 over 4. Okay, I will take that and I'll put it underneath. However, if I'm between 0 and 1, then it's a horizontal stretch. Just recall that behavior is opposite. So instead of this being a 4, it's 1 over 4. If I had 1 over 4x squared, then that's going to be a stretch by a factor of 4. So I'm just going to flip it, okay? So that'll be a factor of 4. So let's look at this, 2x squared. Well, since now we're inside, it's horizontally stretching, right? But in this case, I am shrinking. So I think of this by a factor of 1/2. I'll put it underneath the 1. And I think away from the y-axis here, right? So since this is a 2 here, instead of, we were doing a squared, right? So normally I would be at 1 here, and then 2 would be at 4. Let me just plot those first. And I'm going to shrink that by 1/2 away from the y-axis, okay? So instead of being at 1, I am now going to be at 1/2. So let's change colors here so we can see this. I'm now going to be at 1/2. And instead of here at 4, I'm 2 away from the x-axis, I'm going to only be 1 away from the x-axis. So it goes up here like this. It makes it shoot straight, almost straight up there, going like this. Okay, that's bad. Drop it. So in other words, it's shrinking by a factor of going away from the y-axis, 1/2 away from the y-axis. Okay, so that's when we're doing this. Let's look at 1 here. I'm 1/2 x squared. So normally I'm at 1, and at 2 I'm at 4. Well, in this case now, since behavior is opposite, I think, oh, it's a stretch, and then I flip it by 2. Okay, so instead of it being 1 away from the y-axis here, I'm going to go 2 away from the y-axis. Okay, and then this one is 2 away from the y-axis. I'm going to go 4 away from the y-axis out here. So then my new graph then would be like this. Okay, so it's a stretch by 2 away from y-axis. Okay, because inside with the x is horizontal, outside is vertical. So let's look at several operations here. So here I'm going away from the y-axis by a factor of 1/2. I'm moving to the right 1 and then moving up 1. Okay. So let's first do my normal. Okay, square root of 1 is 1, square root of 4 is 2, so my normal square root function looks like that. However, let's change this color here. This should be 1 away, but I'm doing it by a factor of 1/2, so I'm going 1/2 right here. This one should be 4 away, so instead 4 away from the y-axis, right? So I'm going 2. If I did the square root of 9, which would be way out here, I'd be up here at 3. But I could say if I'm supposed to be 6, yeah, at 3. So at 6, I'm not going to be quite at 3, but I'm going to take half of that. And so I'm going to shoot it right here. So I can take this and it's going to go up a lot quicker there. Okay. And so then that's going to be going up. However, what did I do? I didn't go right 1 and up 1 either. So let's go ahead and change all that. And let's go to the right 1. So here I was at 1/2 and I should go up 1. So I'm going to take that, go right 1 and up 1. So now I'm at a half there. Here I'm at, what, 2, 3. So I'm going to go to the right 1, up 1. And I'm going to be right there. So here are my new points here. And my original, which was at 0, 0, is going to be right 1, up 1. So if I take away some of this here, then my new function, let's go ahead and keep it red, starting here and shooting up. Okay, so let's look. Now we've just got a function here. It's saying this is the function f of x. What are we doing? We're just moving it down 2. So this is already red. So I can just look at my points. Here I'm at 2, 1. I'm going to move it down 2. So I'm right there. This one I'm going to move down 2. This one I'm going to move down 2. And this one I'm going to move down 2. And I'm going to regraph it. Boom. And that's it. Let's look at a piecewise function here. Okay. Here we think, oh, f of -3. Well, I've got to look at, this is basically saying when x equals -3, what does y equal? Okay. Well, I've got to look at these rules here. This is where it tells me which function I'm going to use when my x is a certain value. So if I split that down the middle, when my x is less than 0, I'm going to use the top function. When my x is greater or equal to 0, I'm going to use the bottom function. So -3, that's less than 0, so I'm going to evaluate that with the top function of 6 times -3 minus 1. So that's going to be -18 minus 1, which is -19. F of 0 is going to be my bottom function because it's equal. So it's 7 times 0 plus 3, or in other words, 3. Let's go ahead and box these. F of 4, that's greater than 0, so I'm going to do my bottom function, 7 times 4 plus 3. That's going to be 31. Okay, same thing here. Less than 0, greater than 0, -100. Well, that's greater than 0, so I'm using my top function here. Okay. And, yeah, there we go. Using my top function, splitting it. And so that's just going to be x. Y equals x. Well, my x is -100. Oh, no, it's less than 0. Sorry, I'm up here. So I'm going to be at -3. F of 0, well, that's my bottom function. So y equals x, which would be 0. 125. Again, that's just going to be 125 because it's greater than 0. So it's just what it is. All right, let's graph a couple of piecewise functions and we'll be done. Oh, and then I think we'll do one application problem. So here, I'm looking at where is my split in my x's. And I'm greater than 0 and less than 0. So really my split is my y-axis here. Okay? So, less than 0, I'm at -3. which would be right here. So it's just a constant, so that's my function right there. It's just a constant at -3 when x is less than 0. When x is greater than 0, it's y equals x. So when x is 1, y is 1, x is 2, y is 2, 3, so on. So it's just a slope of 1 going straight up. And that is my piecewise function. However, I do need to do a open circle and a closed circle. Here I have a closed dot because I'm equal. And then here I'm going to have an open dot because it's when it's not equal to 0. Next one, I'm splitting here at 2. So I can think, okay, that's where my split is right there. When I'm less than 2, it's x squared. Okay, so I can think, oh, my x squared starts at 4. When I'm at 2, it's at 1. So I'm just going to go up. And then here I'm at 1, and here I'm at 4. So I'm going to continue up there. But I stop here, and I have an open circle right there. Okay. And then when I'm greater than 2, I'm x plus 2. Well, how am I going to graph that? Well, this is a line with a slope of 1, and it's starting at 2. So I can think, oh, okay, I'm starting here at 2. And I'm going up by 1, up by 1. Oh, look at that. It starts right there where I'm ending there. And now it's just a line with a closed dot, and it's going to be going up by 1 that way. And so I don't need any of this other here. Okay, that is my function there. Okay, let's look at our example here. So write a piecewise function of the monthly charge for a customer who uses X kilowatt hours in a winter month and determine the graph of W of X. So if I have W of X, I'm going to create a piecewise function. So I'm going to go like this, and it looks like I'll have two different functions. So here, when it's 400 kilowatts or less, so that means my X will be between, I can't go less than 0 in this case, so it'll be between 0 and 400. Okay. And what will be my function? Well, base charge is 650, and then it's 0.0650 per kilowatt. So I'm going to put a comma here, and I'm going to put 6.5 plus 0.065x. I did not leave myself enough room to write very well there. Okay. Now, over 400 kilowatts is 0.09 kilowatts. So now this can get a little interesting, but I've got to think, oh, my first 400 is 0.065. After 400 will be 0.09. So I think, okay, that's going to be 0.09x. But I've got to calculate what the difference is between 0.09 and 0.65. So if I do 0.09 minus 0.065, right, then what will that be? So we put that in our calculator, 0.09 minus 0.065. That gives me 0.025. 0.025. Okay. So I've got to take that off of the first 400 kilowatts here. So I'm going to have basically 650, right, is what my base charge is. But for 400, I got to take off 400 of the 0.025, if that makes sense, because for the first 400, I'm getting charged 0.065. And then every one after that, I'm getting charged 0.09. So if I just have 0.09 times x, and if I had 401 kilowatts, I can't charge all of it at 9 cents, right? The first 400 needs to be charged at 6.5 cents, and then the 1 kilowatt needs to be charged at. Okay, so we're just going to calculate it. It's going to be a constant number. So 400 times 0.025, okay, should equal what? 100? Because that's 400 times Yeah, there we go. Sorry, let me get my calculator going here. Times 0.025. Oh, no, that's going to be 10. I'm sorry, I apologize. Because we are at 0.025, it's 2.5 cents, not a quarter. Okay, 2.5 cents. So if I take 400 times 0.025, it's going to be 10. So I'm going to take that away from my 650. So if I have, 6.5 minus our 10, then I will start out at negative 3.5 plus 0.09, let me write this out, 0.09x, only when my x is greater than 400. Okay? So if we did have, let's just say 401 kilowatt hours, that'd be 401 times our 0.09 minus minus 3.5. Okay. So then that should give us right around $32.59. Okay. So that's how we would calculate that. We're going to have 0.09. We're taking away $10 from that because $10 is our first 400 kilowatts, taken away $10. Okay. And then we can just graph that at that point. Okay. You can kind of get an idea of what your graph would look like. But it should meet right there in the middle. So if I have 401.065, that's going to give me $26 minus the 350. Yep. Okay. So that's going to meet up like that. So we've got to calculate and take that away from that one. And I believe that is it for our lesson.